to our video presentation today regarding the Illinois FirstNet project. My name is Bill Springer and I work for the Illinois Terrorism Task Force, and I'm the system architect for the state of Illinois on the FirstNet project. So let's talk about challenges in FirstNet. If you're going to build a nationwide public safety network like this, and this has never been done before, there's going to be a lot of challenges involved with this sort of thing, and a lot of these things we've never tried to do before, so it's going to make a big challenge in this network. The biggest challenge that we've come across is cost. Cost is the #1 issue that people bring up when we talk to them about FirstNet. We don't know what the costs are going to be on FirstNet yet because they haven't selected their network vendor. So they have no idea of what the costs are going to be. However, we do know our current costs for cellular service. We know what we pay, we know what kind of service levels we get, so on and so forth. Also, we know that budgets are tight, and that's going to be a big effect on how FirstNet rolls out, because competitive pricing is the #1 issue that people bring up. Now, FirstNet understands this, and I think we've got to look at this objectively. If FirstNet comes back and says, well, we can give you this FirstNet service for about $5 more a month than what you're paying for your current service, most people can probably swing that. If FirstNet comes back and says, we can do this, but it's going to cost you double, then nobody's going to use the system. So I think FirstNet understands that pricing, and we certainly do in Illinois, pricing is a big deal. Competitive pricing is both for the network service and for the devices. We can't put a network in that can only use specialty devices that are very expensive. If you've ever tried to price out a ruggedized laptop or a ruggedized tablet, those are very expensive. We don't want to have a network that can only use that sort of thing. We want to make sure that the network can use a wide range of devices from consumer grade all the way up to ruggedized grade. Again, to make sure we meet the agency's need, they can pick the level of device that they need to have. One of the other things we've got is, as I said before, one of the benefits of FirstNet is we've only got about 5 million possible eligible users on FirstNet. The bad news is we only have about 5 million possible eligible users on FirstNet. What this does is it's brought up an economy of scale problem. One of the things about the commercial cellular services, the reason they're so relatively inexpensive is that they have a lot of users they can spread their costs out over. We talk about 5 million public safety users possible on FirstNet. Currently in the United States today, there's about 317 million active cell phones in use in the country today. And that's an awful lot of phones in use out there, but what it does for the carriers is it allows them to spread their costs out over a lot of customers. We don't have that same thing in FirstNet, so we've got a lot of challenges there from the federal level on FirstNet to overcome that economy of scale issue that we've got. Also, building out in rural areas. The FirstNet legislation requires that we address the rural areas. We have to provide the service in rural areas. We have to provide coverage. We can't just build this in Chicago and St. Louis and say, hooray, we're done. We have to account for the rural users. The deal is, though, rural usage is expensive. It's expensive to build out in the rural areas. If you look at the pie chart we've got on here, it shows about 5% of the country is considered suburban or urban, and that's about the same in Illinois. The reason that's important is that that's the easy place to build out a network. You've got a lot of infrastructure and a lot of facilities already existing. You've got towers, you've got fiber optic networks, there's buildings, there's all the things you need to put in a network, and you also have a lot of users to spread the costs out. If you take that 68% of the landmass that's rural, there's less stuff out there. There's fewer towers, there may not be fiber optic connections, so on and so forth. So if you're going to build a network out in those rural areas, you have to put a lot more stuff in from scratch, and that drives the costs up. In the wilderness areas, it's even worse. The 7% of the country that's wilderness, it's very difficult because they're protected wilderness areas to put any kind of infrastructure in. So again, the costs are driven up by covering rural agencies. However, we have to make sure we cover those rural agencies by the law. Reliability is another challenge that we've got in FirstNet. The majority of cell site outages are usually due to power and data link issues. That's not because the tower fell over or because anything drastic happened like that. Most cell sites have about 2 to 4 hours of backup battery in them. So if you've got a widespread power outage, after a couple of hours, cell sites start to drop off for lack of power. Most cell sites don't have generators, although the carriers are getting better and better at adding generators to a lot of their sites. So we're starting to see that power issue be solved, but again, it's an added cost. The technology exists to have backup power like the long runtime batteries and generators, but there's a cost involved in that. Also, diverse cell site links. Generally, cell sites are only served by one link. It's usually one fiber optic or one copper connection. If that's damaged or knocked out or flooded or anything like that, that cell site is off the air. The technology exists to have redundant paths to the cell sites, but again, it's a cost issue. It drives the cost up for that. Resiliency is another issue. No matter how hardened you build a site, no matter what kind of effort you put into hardening that site from any kind of a natural disaster or anything like that, eventually the site may fail. The tower may really fall over. So you have to have a way to recover from those failures so if you've got a site that's truly down, you've got a way to get back. One of the ways to do it is the cells on wheels, the cows, the colts, and things like that. It allows us to bring cell equipment into an area and recover that network very quickly. It's really imperative after a network incident like that to get the service back. Like I said earlier, when the world is going up for grabs and everything's going wrong and bad out there, that's when public safety needs to communicate the most. And that's where we have to make sure we've got ways. If a cell site is down and everything else is not working, we've got to find a way to get that network back. So for the solutions to this, we've been listening to public safety. What does public safety consider to be public grade level of service? That's what we're finding out from public safety to understand that. FirstNet's been talking to the national organizations like APCO and so on and so forth. They've also been talking to industry to see how the industry builds those high availability, high reliability land mobile radio networks. So let's compare LTE to land mobile radio. As I said earlier, one of the things that FirstNet said early on in the process was that you'd be able to replace your land mobile radios with the FirstNet system. As time has gone on, we found out that this really probably isn't going to happen for quite some time. There's a lot of technical reasons and a lot of issues with using LTE for public safety push-to-talk radio, and we'll talk about these here in the next few slides. A few years ago, an organization called NPSTC, it's the National Public Safety Telecommunications Council, took a look at what makes public safety radio so special. What defines mission critical push-to-talk? And that's the correct term for the radios that we use every day that we take for granted in our day-to-day operation. That's considered mission critical push-to-talk. NPSTC took a look at that and figured out what's going on in there, what makes that special that FirstNet and an LTE system is going to have to do. And there's several things. One of them is direct or talk around mode. If you use the MABUS Fireground channels or if you use ISPERN or iReach, those are direct or simplex channels. It allows me to talk from one radio to the other as long as we're in the range and we're on the right channels. It's very useful in a lot of situations when you don't really want to go through an infrastructure for all sorts of reasons. The infrastructure doesn't cover you, there's a safety issue, whatever. Since LTE comes from the cellular world, they're not familiar with direct communications. This is not something that the cellular companies normally do. If you think about it, the entire cellular business model is based on one device talking to another device through their infrastructure. They count your minutes and they bill you for those minutes. So cellular companies and LTE, which came from the cellular world, doesn't address direct mode. Also push-to-talk with low latency. One of the things that we expect on our mission critical radios, the push-to-talk that we use, is when I grab that mic and I start talking and I push the button, my expectation is my voice is coming out of a speaker at the other end. No delays, no nonsense, no nothing. That has to happen because lives depend on that. The commercial cellular world and LTE, they haven't reached that level yet with their push-to-talk. There can be delays, there can be slowdowns in there, so they really don't have that part of it down yet. One of the other things that LTE can't do is group call. One of the basic things in radio when you're talking on the radio is when I talk on the radio, I push my mic button, start transmitting, everybody around me who's on the same channel and is within range will hear me. It's just basic to the way radio works, it's just natural, we take that for granted. In the cellular world, they're not used to that. In cellular, they're more used to one-on-one conversations. I'm taking my cell phone, I'm going to dial the phone, I'm going to talk to you. We're going to have a one-to-one conversation. If we want to have more than two people in that conversation, that's considered a group call and that's extra call setup. So that's an issue in the LTE world. They're not used to group calls. And there's several other issues as you can see on the slide here. The standards bodies are looking at this, but it's going to be a few years at least, if not longer, before they have standards that address all of these things. And again, those standards have to be tested, implemented to make sure that they actually work the way we think they should work in public safety. So the takeaway is that land mobile radio is here to stay. If you've got a land mobile radio system, continue to invest in that system. It's not wasted money. You're not wasting your money when you maintain, upgrade, and replace those systems whenever you were normally going to do it. One of the things we've seen around the country is when agencies may go to their governmental bodies to get budget to replace their radio systems, there may have been people that heard about FirstNet early in the process. So the thinking is that, well, this FirstNet system is coming in and it's going to take over for your radio systems in a few years, so let's not spend the money now. That's not the case. They won't be able to take over for at least a decade, if not longer. So if you've got to maintain those systems, spend the money, it's not going to be wasted. We just wanted to make sure you're aware that in talking to your county or city or whoever your elected officials are, this perception may be out there, so be prepared to address it. So for radio over LTE, there's reasons why we can't do it. To summarize, there's no standard for mission critical push-to-talk over LTE. The standard has not been finalized. They're still working it. It's still a few years away at least. Commercial push-to-talk is best effort, not mission critical. Again, that's the key difference between the two-way radio systems we use and a cellular type push-to-talk is when I push that mic button, I'm being heard somewhere immediately. Also, site density is an issue with LTE. Whenever you've got a portable radio that you're using on a two-way radio system, they transmit at about 5 watts. Usually between 3 to 7 watts, but somewhere in there, 5 watts is a good average. My LTE device, when I'm transmitting on that, it transmits at less than half a watt. So there's a huge difference in power levels between the two types of devices. So if I have to have towers out in the area to pick that signal up, where I could usually have one tower to cover an area for a portable radio, current studies indicate that it takes 5 to 7 towers to cover that same area for LTE because the device power is so much weaker. So site density is a huge issue, and it's going to be a while before there's enough sites out there on FirstNet to reliably handle push-to-talk transmissions. Also, no LTE mission-critical push-to-talk systems have been demonstrated, tested, or deployed, at least none that have been built to a standard. There are some manufacturers who have demonstrated some push-to-talk systems over LTE. They look promising, however, they're not built to a standard and they really haven't been tested and make sure that they actually work. So again, land mobile radio and LTE, this is a long way off, several more years at least. FirstNet at the federal level has finally come out and started saying that they're not planning land mobile radio over LTE for the foreseeable future, at least a decade, if not longer. Land mobile radio is going to be your primary tactical communications tool for a long time to come. And when you think about it, land mobile radio and LTE are two separate but complementary missions. Land mobile radio is that radio transmission for short communications for the responders in the field, the people that literally have their hands full, whether they're handling a fire hose or they're packing sandbags or whatever it is they're doing. When they need to communicate, normally those people in the field, they grab the microphone, make their call, wait for their answer, and go back to what they're doing. That's the perfect mission for land mobile radio. LTE provides that mission critical supporting data. So if I'm doing a fire scene after a fire and I'm documenting it for an arson investigation or something like that, that's where LTE uploads all that information. Or if I have to document where I placed all my sandbags, LTE allows me to take a video or do a map or something along those lines to document it. So again, two different missions. They're different, but they're complementary. So let's talk about Tband radio systems. In the FirstNet law, one of the things that got into the law was that in return for getting the FirstNet spectrum, that 20 megahertz D block, public safety had to give back what's called the Tband in the UHF band. This is in the federal law. This was part of the process of writing the law. So some background on Tband. These are UHF radio systems. If you're not sure if you're on Tband, this occurs up in the Chicago metropolitan area in Illinois, usually in about a 50-mile radius from downtown. So if you're in certain counties up there, you can check your license. When you look at your license, check the frequencies. If they start between 470 megahertz and 512 megahertz, you have Tband channels. Tband stands for television band, which are unused UHF channels, UHF TV channels. This is in 11 urban areas around the country, including Chicago, and it provided relief for a crowded spectrum back in 1971. Even back in the late 60s, early 70s, the FCC recognized there are spectrum contention issues in the large cities, so they released Tband for use for public safety. The important thing to consider is, and this was done in 1971, spectrum congestion is even worse today. It's almost impossible to get new frequencies to license in urban areas, including Chicago. So as part of the FirstNet legislation, again, in the legislation that was approved in 2012, it requires public safety to vacate T-band by 2021. The spectrum, once they get everybody off of it, is supposed to be auctioned. This is a federal law to be enforced by the FCC. One of the misconceptions we have is that this is the FCC doing this. It's not. It's federal law. The FCC has to enforce what Congress told them to do. The big takeaway is time is short. There's only 6 more years until 2021, and that's not a lot of time when we're talking about replacing radio systems. Here in Illinois, we've identified 4 possible options to address the T-band issue. There may be more options. These are just the 4 that we came up with that seem to be the most likely. All of these have costs, they all have risks, and all are going to require time. So the 4 possible options, the first one is to wait for mission critical push-to-talk over FirstNet, to wait for that technology to come into play where it's usable. We consider this the highest risk option because we don't know if the technology and the infrastructure is going to be in place where it's usable and reliably usable by 2021. That technology and network may not be ready in time. We don't know if it will be or not, but this is a very difficult thing to address. That's a high risk. It's going to require equipment replacement. Obviously, the portable radios that you've got today on T-band are not going to work on FirstNet. So even in this scenario, there's going to be a cost. The second option that we see is political lobbying to change the law. Anytime that we deal with political issues, it's impossible to predict the outcome. There's only 11 urban areas affected out of the entire 50 states in the U.S., so it's going to be impossible to say if Congress will readdress this or what they will or won't do as far as the T-band issue. If we do get the law changed where you don't have to vacate T-band, if you recall back a few years ago when we were in the middle of the narrowbanding project, when the FirstNet law came out, T-band licensees were told you don't have to narrowband because you're going off those frequencies shortly. If we get those frequencies back and we don't have to give the spectrum back, narrowbanding will probably be required if you haven't narrowbanded already. So again, there's going to be an additional cost there. A third option is to exchange the T-band spectrum for other spectrum on a one-to-one basis. So if your agency has 2 or 3 or 4 T-band channels, you could try to get other spectrum to replace that in another frequency band. In the Chicago metropolitan area, there's not enough spectrum for a one-to-one swap. The spectrum simply does not exist. Also, assume for a second, just for a discussion, that we want to go from T-band to 700 megahertz or to any other spectrum. This is going to require re-engineering. The propagation characteristics, in other words, how well the T-band signal covers, is different from T-band to 700 and 800 megahertz to VHF. Anytime you make that big of a jump in your frequency band, things are going to change from an engineering perspective. It's not just I'm going to turn in my 470 equipment and pick up my 700 equipment, turn it on, and it will work. It's going to require re-engineering to make sure your systems cover the same way that you're used to before you made the swap. So there's going to be added costs in the exchange of spectrum. The fourth option we've identified is to join regional or statewide trunked radio systems. This could be Starcom on the statewide system. There's other regional systems in Illinois that's possible to join. The shared systems are very spectrally efficient. The FCC likes to have agencies sharing frequencies and sharing systems, but costs are going to be different. Whereas before, when you had your own T-band conventional system, you bought your radios, you had a service contract, that was about it. In some of these shared systems, there's a monthly fee for using the radio. So it's a different budgetary item. Also, there's a loss of control. Agencies that were used to setting their own policies and procedures for the use of the radio now have to adapt to a shared model. That's a hard thing for some agencies to get used to. We understand that, but there's an issue with loss of control, and we get that that's going to be something that agencies would have to address. Unfortunately, we don't have any good answers for this T-band issue. All the options we've put out there all have drawbacks. They're all going to cost. They're all going to take time. The key is that time is very short with T-band. 2021 is only 6 years away. In that 6 years, you have to do planning. You have to get into your budget cycle to make sure you've got funding to do this. You need to do a procurement. You need to implement whatever solution that you're going to have to do to get off of T-band. Again, only 6 years, that is not a lot of time. If you're going to do something, now is the time to start. One of the things we highly recommend is that you go to www.nipstick.org/tband.jsp and download NIPSTIC's Tband report. This is a very good document that explains all of the issues surrounding Tband, all the implications of having to vacate the band, and all the things that are going to pop up in this process. It's a very good document because it has a very easy to understand, plain English executive summary that explains things in a very clear manner. It's also got a lot of backup documentation that explains their position. So if you're on Tband and you're facing this situation, it's highly recommended you download that document and start planning today.